Now, what is meant by electromagnetism? Electromagnetism means when current passes through the magnet and that particular device or that particular magnetic material converts into a magnet. I'm talking about a magnetic material. Magnetic material means it's not a magnet, but it will converts into a magnet. Okay. So important thing is it should be a magnetic material, but that magnetic material will be a sort of magnetic material in which once the electricity will pass, it will become a magnet. Now, remember one thing, in the last few classes, most of our students are not there. So quickly, I will review what we have done in the previous class. There are two type of magnetic materials we have it. Okay. One type of magnetic material is called a soft magnetic material, and one kind of material we have it is called as hard magnetic material. Now, what is first of all magnetic material? Let me quickly come to this point so that you will understand. See, magnetic materials are the materials which are attracted by the magnet. Okay. Now, in this category, there are two type of material. One is called as hard magnetic material, like steel, and the other one is called as soft magnetic material, like iron. Now, hard magnetic material, there is a difference between a magnetic material and a magnet. Magnetic material is attracted by the magnet, while magnet itself attract magnetic material and the other magnet, right? So here, why we call them hard magnetic material or soft magnetic material, there is a reason behind. The hard magnetic material have a tendency to become a permanent magnet. If you want to if you want to magnetize them, they will magnetize permanently and they will not demagnetize once the you like remove the force or whatever you want to do it. On the other side, soft magnetic materials are as per your wish. They will become a magnet once the phenomena is applied, and once the phenomena is removed, they will again come back to their original shape. That is the reason in all the devices, rather than we are using hard magnetic material, we used soft magnetic materials because soft magnetic material have a tendency to become temporary magnet for the time being. If you check it out, it's written here electromagnet. Electromagnet, as the name suggests, once the electricity will pass through the magnetic material, soft magnetic material, they become magnet. And once the electricity is removed, they came back to their original shape. On the other side, permanent magnet, if you use it, for example, once the electricity will pass through them, they will become magnet and they will not be demagnetized even if the electricity is removed. So that's the reason we don't use them, but we use them in our devices. Anybody, in which devices you see this iron to be used in electromagnetic devices? Any ideas? Any guesses? They are used in transformers. They are used in electric bulb, electric bell. They are used in switches. You never see this permanent magnet used. I mean, you never see a hard magnetic material used instead. You will never see a transformer made of steel. It's always made of iron. The reason is very simple because once the electricity will pass, they will become a magnet, and we want them to be demagnetized once the electricity is removed. So, for that purpose, soft material will be used. Now, let's talk about electromagnetism, which we will be talking about, which we were talking about previously. Electromagnetism. Now, this is interesting fact. It is actually found out by a scientist named Hans Ørsted in 1820. What he noticed is he actually got a wire here, and from a wire he passed a current through it. And once the current is passed through the wire, and he put you can say a compass needle. You know, a compass needle has a speciality, but whenever there is a magnetic field, it starts showing deflection. So interesting fact is when the current was passing through the wire, it shows deflection. It means that very near to the wire, there is definitely a magnetic field. So that fact is actually found by Hans Ørsted. So this is what we call as electromagnetism, right? So I want you to quickly write this electromagnetism heading and write these words quickly. And student, one more thing. I just want to show you your timetable. I think we have to change one of your class only. Rest of the class will remain the same. We have a timetable here, which we are following due to Ramadan and all this. That 9 o'clock slots. I mean, this one and this one and that one. The one which is at 5 o'clock will be fine, right? The only class which is there somewhere, where is it? This one, which is on Monday, Tuesday, Wednesday, Thursday. Thursday, we have a class as 4 o'clock. I'm asking you this question if it's possible
जनाब
that.
जरा
जी जी बोले जी yes. Actually, I just want to ask you about this class. Can we shift that class somewhere ahead? I mean, ahead of time, somewhere here at about 7, 8, or 9 or 10 out of these 1, 2, 3, 4 slots. If it's possible at 7 o'clock or 8 o'clock would be fine. Yes, students. Okay. So we were talking about electromagnetism and we were talking about that once the current is passing through the wire shows magnetism. That's what actually found out by Hans Oersted. And Hans Oersted, what he found out that the compass needle shows deflection. Because we know that whenever there is a magnet nearby, compass needle show deflection. So that's what he actually found out. And he says that thing is called as electromagnetism. It means that once the current passing through the wire, the magnetism is produced inside the wire and it becomes an electromagnet. So wire which is shown, that particular phenomena is called as electromagnet and the phenomena is called as electromagnetism. Right? I was asking you to write it. So can you write it quickly? Ibrahim, you too? Now check this out. Magnetic field pattern around the wire, straight wire. Now, if you check this out, this is interesting actually. If current is going in the downward direction, which it shows, right? Now, what the scientist says is, if it goes in a downward direction, the magnetic lines of force or magnetic field is produced around the wire in a circular way. And it's written here concentric circle. It means that the magnetic fields are in circles, and every single circle that shows a magnetic field, whose center will be that straight line. That is meant by the concentric circle. Now, point is how to find out the direction. And the direction can be found out by right hand thumb rule. Like, for example, if this is your hand, right, and you grab the wire in this direction and current goes in the upward direction, this direction, where your thumb is pointing in the upward direction, then your finger curlings showing the direction of the magnetic field. In this case, the direction of magnetic field is in circle, but in anti-clockwise direction, this way, against the circle. So, the rule which is used to actually find out the direction of the magnetic field is called as right hand grip rule. Same thing if you check in the previous example. When the current is in downward direction, your thumb should be in the downward direction like that. Grab the wire in an opposite direction and your thumb should point in the downward direction. Then your your magnetic field direction will be like this. So direction will be clockwise. So if you check this out, these circles, the direction shown is in clockwise direction. Guys, any problem in understanding this? Ibrahim, Yumna, Armina?
No, sir.
I want you to write this, please, quickly. And draw the diagram as well.
Sir, did we not write this in the last class?
I think so, we have, but not everyone, I think. That's the reason I have reviewed it. I will just move it on.
Sir, so should I write it?
If you write it down, then there is no need. If you wrote it down, that's fine. Because only there are two people, I think you and some other person. So I better go through with it.
Okay.
Yeah. So if you write it down, you don't need to write again. Those who are writing it, who write it first time, read it and find out if there is anything you have a problem. Very straightforward things are written here. Consist of concentric circles centered on the wire. The magnetic field is stronger near the wire. Very simple. If you are very close to the wire, the magnetic field is much more stronger. And then field lines being closest together near to the wire. As you move closer to the wire, the field lines will be more and more concentrated. The strength of the field increases if the eccentric current is increasing. It simple means that the value of current will increase, the magnetic field will increase. All right.
Yes, sir.
And students, now you tell me, once we finish with this magnetism, I want you to have a test for that. So, which chapter you want me to take a test for? We already done how many chapter? I will let you know. Waves and sound is completed. Inshallah, till that magnetism and electromagnetism will be completed. We have electricity, that one we have done as well. We have atomic structure and atomic energy. We have done that one as well. So 4 or 5 major topics, major things are actually we have done that. So I want to have your test for this. What about if I take a test for waves, magnetism, and electricity? Are you be ready? Yes. Hello. Anyone? What happened when I say test? Nobody is responding.
Wait, like an oral test or written?
All in one test. 3 chapters: waves, electricity, and magnetism and electromagnetism. 3 chapters in one test. Right after finishing this chapter, which we are doing right now. Will that be fine? I think hopefully at the end of the second week, nearly at the end of this month. I will let you know when the test will be. Okay. So get yourself prepared for these 3 chapters. Armina, will you be will you be okay with these 3 chapters? Ibrahim,
Sir, can you repeat? Actually, my internet is very slow.
magnetism and electromagnetism. Second chapter will be waves and sound, and the third chapter will be uh, what did I say? Electricity. 3 chapters.
So all in the same day.
Yeah, one complete comprehensive test for 1 hour. One more chapter we have done, I forgot to tell you, that is light. So we have already done too many chapters now. I think we better have a small test as well, so that I want to see how good are you in the test. Okay. So get ready yourself, buckle up yourself, and before examination, I will take your 2 or 3 tests so that you will be ready for the exam. I really want to see that. Okay, then move on. Next. Now, if you see this diagram here, they give you a diagram of a right hand grip rule. That is to find out the direction of the right hand grip rule. Now, right hand grip rule said that if, for example, you have a wire like this, okay, and you want to find out the direction of these magnetic fields lines, then grab the wire in the direction so that your thumb will point out towards the direction of the current. If it goes upward direction, then these finger curls will show you the direction of the magnetic field, which is in anti-clockwise direction in this case. That is what we called as right hand grip rule. I want you to write this from here to here and draw the diagram. Don't show the thumb, but show the direction. Okay, and show this circles on the paper as well. Please, quickly. Okay, students, have you written it?
Yes, sir.
Yes.
Okay. Now, another very important point, which inshallah will help you out. Now, check this out. How will it be shown? Okay. Now, if you check this out, current direction is moving upward. It look like that if this is your page, right? It is going upward means out of the page. So if, for example, the diagram shows with a dot in between, it means the direction of current is out of the page. So you can say magnetic field direction out of the page. And if this thumb direction is in the downward direction, it will show like a cross. This says into the page. I want you to draw that circles along with this cross and everything. And guys, I am sharing with you a small screenshot that is related to the sign conventions. Same thing. So I want you to quickly see that. Okay. When the thumb is upward, everybody sees it. I've just sent it on the group. When the current direction is outward, going upward, you can put a dot and it will be current flowing up means out of the page, and current flowing downward into the page. Okay, now next. Now, if you check this page out, students, check this out. This is very interesting. They're saying complete the diagram, right? Now, step by step, they have completed the diagram. First thing first, add the field lines, then add the current direction, add the direction, add the field line, up to you. So, one thing must be given to you. If this cross is given, it means that you're going into the page. Thumb direction is in downward direction. So, direction will be clockwise. If that dot means thumb is upward, direction will be anti-clockwise. Okay. This is just to show that there is nothing very important about this, but you should just need to know the direction things. Now, solenoid. What is meant by solenoid? Initially we have a wire, right? And that wire, you can see a wire, once the current is passing through, it becomes a magnet, right? The point is, even if you increase the current too much to a limit of a wire, the magnetism is not that much stronger. But when that same wire is curled like that, and then current is passing through, we have seen that magnetism is increasing. So basically, when the wire is curled, that wire which is curled wire and in this shape is called as solenoid. So once the current is passing through the solenoid, the intensity of the magnetic field increases. So I want you to write from here to here, only draw the first diagram. Do not need to draw the second one. First diagram and write everything. Okay, next slide. Then.
Yes, sir.
Okay. Everyone wrote it?
Yes.
Okay. Now, before we actually see what is the direction, there is a right hand grip rule to find out the direction in case of solenoid as well. Now, what is that right hand grip rule? If you just check this out, if you see a hand, right hand is actually going on right to left. Why? Because the current direction is from left to right like this. So if you check it out, if the direction is going in the direction of the current, if current is going from that side to the left hand side, then these curl fingers will give you the direction of current movement. And remember that the curl fingers will show you the direction of a current, and the finger are placed in the direction that are eccentric current flow. The thumb is pointing towards the north. Again, if the current is going from that side and your thumb is pointing in the direction of current, then these curl finger definitely show you the direction of a current, which is in that case is anti-clockwise. Then this thumb is actually pointing to the end, which is a north pole. For example, if current direction is from this side to that side, then the thumb will point in that direction and the current direction will be like this. So in that case, the north will be there and south will be there. So now in solenoid, you will have a north and south directions as well. This is what we called as right hand pole rule. Okay. Now for this one, let me come to the detail of this, which is in this particular, not that one. Check this out. Why I have showed you this, check this out. This is your wire. We have done this. The current is passing through this and it shows nothing but just concentric circle directions, which we were talking about previously. This dot represents current flowing upward out of the page. We have already talked about this. This is going inward, or you can say current into the page. Now here, this one we have already done that. Now this is solenoid. We have already talked about this. Then if you increase the current quantity or if you increase the number of turns, we have already seen that magnetic field will increase. Now this is the diagram I want you to understand. And this one you can see that it can be given by right hand grip rule. Now check this out. What exactly it is. Let's suppose the current is flowing from left to right. This is the flow of current. Current goes from here, this way. Can anybody tell me what is the direction of current? Anti-clockwise or clockwise? Yes, what is the direction?
Anti-clockwise.
It's
Anti-clockwise.
anti-clockwise. When the current direction is in anti-clockwise, the thumb pointing towards the end is called as north pole, and the one which left behind is south pole. If current is going from that side, the direction will be like this. Then the current direction will be clockwise. In that case, the thumb will direct in this direction, and that side will be your north, and that side will be your south. Same thing here. Check it out now in this diagram. You can understand this diagram now. This is your current. Okay. Now this is your plus sign. Current goes from here and it goes here like this, anti-clockwise. We have already seen if current goes anti-clockwise, like here, if you see that, it is actually technically the previous one you have talked about is clockwise because the coil is in this direction, right? So here, if it goes anti-clockwise like that, right? So if you grab your current direction and your finger curls in the direction of the current, so basically current direction is like this. So if you curl that, the thumb pointing towards the north side like this. Okay. So this way, if it's north, this is south. Now we can draw the diagram of the north pole and the south pole. That magnetic field start from the north and end at south. North start and end at south, north and end at south. Remaining is the same north and south thing. The only makes a problem, an issue for the student is, again, I will explain if you have any problem in this. See, the current goes this way. Technically speaking, current goes this way. This is anti-clockwise. Now, if current goes anti-clockwise, which way do you grab this wire so that your finger will curl in anti-clockwise direction? This is a straight horizontal wire. Which way do you grab that so that it will be in anti-clockwise direction? Can you do, everybody? You better move your thumb in this direction and curl your finger. Check it out which way your fingers will curl. If you move your thumb, if you just move your thumb in this direction and curl your finger will go in this direction, anti-clockwise. Guys, everybody understand this?
Yes, sir.
So basically, when current is going from this side, we don't need to see which way the current is coming up. We just need to say which way we can curl your fingers so that the direction of the current is established. If you grab your finger with a straight hand moving on the left hand side, moving your thumb on the right hand side, and you will curl your finger curl will be in anti-clockwise direction like this. So it means that your north will be here and your south will be here. If the battery will be here, for example, and current go like this, so it will be like this. If, for example, the battery will be like this, in that way, the north should be here and south should be here. Ibrahim, Sufyan, any problem in this? Or still a problem?
So can you explain again?
Again, okay, no problem. If you see this direction, they say that current flows in this direction and coming out on this direction. Don't be confused which way the current is flowing. Just remember the direction of the current. If current goes from positive, the direction of a current is in anti-clockwise direction. Anti-clockwise, like this. Now simply remember that if current direction is in anti-clockwise direction, the only way to curl your finger is in anti-clockwise direction, that your north should be on the right hand side and your south should be on the left hand side. Understood? Keep your finger, keep your thumb in the right hand side and then curl your finger. Same way as he did it. You will see the finger curling will be like this. Like this. This will be anti-clockwise. So anti-clockwise direction of the current can only be established if this thumb is heading on the right hand side. So when the current is established in anti-clockwise direction and your thumb shows the right hand side, then the right hand side of a thumb is a north pole and the other side is called south pole. Now, Ibrahim, any problem in this? Yes, students, any problem in this?
No.
Okay, then copy that and draw both the diagrams now. The one on the left and one on the right. Or what we can do, we will leave our today's class, inshallah, tomorrow or next class, which is as per schedule, on Monday, I believe, we will continue with this. So from now onwards, the Thursday class will be at 7 p.m. PST. Okay. All the remaining classes, all the 3 classes will be as per schedule. Okay, then see you in the next class. Okay, bye.